So, well, let's talk about the remodel first, get it out of the way. So the main thing, actually go to your canvas and get out the file that has, I'll get the name of it, hold on. Johan and Sherry Trujillo. You see that print?
Yeah.
And the second page of that so does everybody see that on the screen?
Yep.
Yes.
Okay, I'll see if I can. So this floor plan, see the code at the bottom says this is like a regular wall, on a blueprint floor plan. So that's the wall to remain. And then the demo wall is dotted lined. And this is the new wall, I guess. Right? Yeah.
Sorry, Pat, where are you looking on this plan?
Well, I'm sharing the screen.
Yeah, I could see it.
Oh, okay. So down at the bottom, you see the key down there?
Oh, sorry. I have, yeah, now I do.
Is that Alec?
Yeah.
Okay. Yeah. So I was just going over this. We could make it a little bigger even.
Gotcha. Sorry, I had some of the sidebar cameras down, so it was blocking it. So
What did I do? I
Got it.
turned it over. That was interesting.
yeah, now it's upside down.
Okay. We'll get there someday. There we are. So you can all see this key, right? In the lower right. So
Yeah.
the regular way we draw it is the walls that stay. And then the new walls are in black, and then the demoed walls are in outline. So when they do that on a floor plan, on a remodel, they'll usually have some kind of key. It won't always be these three. They may vary, but they'll be different. So in this one, this has an existing house that's from the back, it comes down, and then this is the front. It's got a porch, and I think it goes like this, and then goes to the garage. So all this is new. This is added in the front. It's pretty deeply, it's set back, interestingly, and that allows them, I guess there was a yard here next to the garage, that allows them to rebuild that whole thing. And then there wasn't a room behind this is a pretty small house. There wasn't a room behind the garage, I don't believe. And they added they put the kitchen here. It used to be, oh no, I'm sorry, I made a mistake. The house went like this, and then it came down like this to the garage. So they added some to the front, and then they demoed the rest of that living room and whatever that was. That was probably the original kitchen. And they demoed it, and they made a bigger room out of it, brought it more toward the front. Y'all see that? So anyway, what I'm just trying to show is how you can talk about what you're going to demo with the dotted lines or some other symbol. And then you can put with the bold lines, which makes sense because it's how it's going to end up. You have the new walls, and then these are existing. The back of the house doesn't change. The garage doesn't change. Everybody got that?
Yes.
That's about all there is to say about that. Now, the other thing is, I wasn't going to use this, but I decided I need to. Okay, so the other thing is when you have a wall, this is the plan view. And this is the existing here. And you're extending that wall, right? So when you're remodeling, which this would be, you're doing a room addition. There's several ways you can join these walls. So if you want to have it look like there was nothing there, I mean, no change, and it always been, say it's a stucco wall, then you'd have to break out the stucco here and then, stucco and integrate it. And when that is exactly the same as the old wall, we call that coplanar. Well, I call it coplanar. I don't know if anybody else uses the word, but it's a legitimate geometric word. And it just means you're extending the plane perfectly. But there's other ways you can attach a new room or extend a wall. You can jog it out a little bit or jog it in a little bit and either have the same surface like stucco and it would just have a little jog. Right? And that allows you not to have to make that smooth. Some surfaces are hard to join like that because the old material is not replicable. It's just not, you have to do, flip-flops to make it work. So you can shift it a little bit. The other thing you can do is either shift it or keep it coplanar, but use a different covering material. So if this is stucco, you might start this wall. If it's coplanar, you could put siding there and have the siding stop where the old stucco is. And that way, you see that all the time, alternating stucco and wood. And but it's a great way to not have to worry about that joint. If you do a coplanar with the same material, you've always got to worry about that joint. And if someone does a slightly crappy job, when the sun hits that stucco, looking straight on in the shade, you're not going to notice it. When the sun hits it and you're at an angle, you're going to see a line. So that's hard in sheetrock and anything you're using the same surface. That's difficult. Good stucco people and good sheetrockers obviously can do it so you won't notice. But these are just ways you can avoid having to do that. So changing material, jogging the plane so it becomes two planes are ways to do that. When I created a class 119, it was called Remodel Construction, and I wanted to talk just about this kind of stuff, choices you had when you're remodeling. And then Jim started teaching the class. When I created more, I had to teach the new ones. And he just treated it like CT 110. And I kept saying, no, if it's like 110, we might as well not have that class. It's a duplicate. So eventually we got rid of it because I was ticked that he never taught it as a remodel. He did a little bit of remodel, but he would teach it out of the book, and the chapter in the book I don't think is that good, but he knows a lot of tips just like I do. We've been carpenters all our lives, and there's a lot of really cool tips with remodel that that are useful. So, but we don't have that class now, so you're on your own. Okay. So, let's start in on the commercial framing prints, get those out of the way. And those would be did anybody have a chance to read those? Of course not, you're all
Yeah.
busy. Okay, can you see this?
Yes.
Okay, great. Commercial framing prints. Now this class is this whole program at City College is a residential construction, but I think it was maybe Marcos or some of you wanted to see if we could talk at all about commercial. And I said that, well, we couldn't a lot because there's enough to cover the residential. I said I'd do a little bit. So this is part of that little bit. So I'm going to show some of the basic steel and concrete concepts and practices that go into these buildings. And then I'm going to show a couple little short YouTube clips that are kind of fun. So, so commercial buildings, especially ones with multiple floors and elevation, are almost always steel and concrete. Because for one thing, wood is hard to build where you go high, although, and John knows this because we've talked about it, they're doing a lot of, what do they call that, John? That new construction with wood?
Mass timber. That's
Mass
Mass.
timber?
Yes.
Yeah, thank you. Yeah, so John and I were looking those up in another class a while back. And you can look that up. It's really interesting. So because we'll run out of iron ore and anything that goes into steel eventually, we won't run out of trees. So somebody said, well, shit, why don't we try to build tall buildings, multi-story buildings out of wood and see what happens. So there's a whole industry now, a parallel industry all over the world. If you go on YouTube and just say mass building, you'll get YouTubes from all over the freaking world. And they're beautiful buildings. And they're really interesting, and they're just wood, which is a much more environmental product because we can keep growing trees if we manage it well. But a lot of these other things we're going to run out of. You know, concrete or cement, the big part of concrete is anybody know the chemical? It's what is it? It's got calcium in it, I believe. It's a calcium with
Lime?
oxygen. Calcium citrate or something like that. I forget. But you know, it occurs in nature, and we mine it. But you know, we're going to run out of it, especially at the rate we're creating big cities that take concrete floors, like we're going to look at. So this wood, this mass timber is a great idea. Its time has come, and I'm pretty excited about it. You may never see one of those around here for a while, so we have to talk about the traditional way of building these things. So in this chapter, they talk about concrete, cast in place concrete, which means, you know, they pour everything right on the site. And then the other one is, what do they call it? Prefab. Let's see we'll go back to that stuff. God, precast concrete. So here's a picture of a precast. They make these in a factory, and they have to have big cranes, obviously, to lift these up. What do you think that slab weighs? That's a pretty good, hefty slab, huh? Let's put it this way. You wouldn't want to be underneath it when they lay it down on the ground. So they don't do as much of this precast in big buildings. That's probably more common in slightly smaller buildings where they don't have that many of those walls, and it makes economic sense to cast them and then bring them to the site. Transportation costs a lot. Gasoline, flying, however they wouldn't fly them, but however they get them, that adds to the cost quite a bit. So there's a steel structure, which we'll look at more of. So obviously we're talking about reinforced concrete. You got to have a lot of steel with rebar and various things, metal things inside the concrete to give it strength, the strength it needs. You see places in the world where they don't use reinforced concrete, but just plain concrete. And eventually an earthquake comes to that village in China or wherever, and the whole damn school building falls down, sometimes killing kids, sometimes not. You got to do it. Concrete's brittle and just cracks if you don't have something holding it together. So these distinctions aren't that important. They have various ways. They'll run girders out of concrete, and then they'll have beams going the other way. And then the slab, it's all integrated on top. So you don't have to know that stuff. If you're interested, you can just sort of gaze through that. Then they have columns. Well, these are sections of rebar. And this just shows the markings on it. And, when you do residential construction, like average middle class homes like we have here in Santa Barbara County, you're going to use your basic, 5, 6, 7, 8, whatever the numbers are, rebar that you get at Home Depot, and that's it. You don't have to think about it much more. The architect on the plans will designate the size. And remember, the size goes by 1/8 of an inch. So if you have a number 3, it's 3 times an 1/8 or 3/8 thick. If you have a number 4, it's 4/8 or 1/2 inch. So 3/8, 1/2 inch, 5/8 on up. And you just go to the, Home Depot or Hayward and buy the lengths of that you need for your footing and your foundation. But with commercial construction and these big buildings, it's a lot more important to have the exact kind of steel you need. So this just explains all the different identifying marks. And the plans will tell you, they'll just list all this stuff. They'll say for these, the rebar in this section, it's got to be, say this, all these requirements. When you have posts or columns, this is a plan view, and you'll have rebar in the center, and you'll have vertical rebar every so many inches, and that's spelled out how close they have to be. And you might have a squarish column, and it'll be the same thing. It'll have vertical rebar, and then it'll have, things that hold it together. When you see these cages, we call them. You've probably all seen those at some point on a site. Yeah. So if they're in the ground and on a hillside, they call them caissons. But any column could have these. I mean, caisson's kind of the where it's used. Yeah. So, and then the beams, sometimes they integrate the beams with the columns and they just pour it together, and there's all this rebar in it. So it's what's called an integral pour. This looks like it was poured and the rebar stuck up, and then they poured another column for the next floor on top of that. Let's see. These are just shapes of types of concrete. They made a mistake and didn't talk about the way rebar is spliced inside these systems. And here it doesn't say anything, and then it says other splicing methods such as mechanical fastening and welding are also used. So mechanical fastening could just be, what do you call it? John, what's the wire called that you use in rebar?
Ties.
Yeah, ties,
Tie
but what's
wire.
just that roll of wire called? Tie wire maybe, huh?
Yeah.
But I don't think,
Icon.
yeah, but I don't think in a building you can get away with that. Because you're putting a lot of stress on these concrete floors and beams. And I bet they have to be welded, or maybe there's some other mechanical fastening besides just wiring. I don't know. I don't do this. So maybe if anybody does this, maybe they can get away with wiring if it's done. I mean, whatever's done, the inspector's going to look at all the joints before you pour.
Are you
And
talking
maybe
about
you-
belling, like belling wire or like the grounding wire?
No, just a wire, just a wire that you fasten the rebar together with.
I've always known it just as belling wire.
Yeah, but on a residential home, right?
Yeah.
Yeah, so that's what we use. We just use wire, or we have the you know, the wire that John, what'd you say those are called? The
The tie wire,
yeah, the tie wires, and you have that little gadget that puts it on. So yeah, we can do that because the concrete's not taking the same kind of stress. You know, it's a foundation, so it's got the freaking ground underneath it, right? So it's not really going anywhere. But when you're talking about 10 stories up and you got a floor with concrete beams in it, you don't want any, you know, unanticipated deflection or breakage. So maybe there's a way to tie those that's good enough. They just tie the crap out of them and the inspectors say that's fine. I don't know. Is anybody?
Wire, bigger wire or something like
Yeah,
that?
maybe bigger wire. I don't know. Has anybody worked on concrete, on steel and concrete structures where they've done the rebar in the
Not
floor?
up in the air like that. No, not
Yeah.
anything above couple
Yeah.
stories, 2 stories.
Okay. Well, it doesn't matter. But somehow the joints are lapped. You know, they do a lot of welding in steel construction, so maybe they just weld the flipping bars together. And then expansion joints. This is something we don't have in homes very much. Although in cold climates, they do sometimes leave expansion joints even in a residence, because there's so much difference in temperature, max and minimum, that the concrete actually goes to a lot of expansion, more than in a, you know, place like Santa Barbara.
Don't they sometimes insulate the
Yeah,
slab all
they-
the way or something?
Yeah, I think they had expansion joints, and then when they started getting conscious of the importance of insulation, somebody said, "Hey, can't we stick a 1/2-inch piece of foam down there?" And somebody said, "Sure, why not?" Yeah, because it could still expand through that. It would just crush that foam. But yeah, they do that too, which would make it a non-monolithic pour. They would pour and as Duke said, they might even pour the footing and then pour the wall, like a basement wall, into a key as second pour, and then maybe even do the slab as a third pour if it didn't
Yep.
touch.
Yep.
So, and then pre-stressed concrete, that was an interesting. I didn't know any of this because I don't know anything about commercial construction, but except that it's freaking overwhelming. I can't imagine someone building a skyscraper. But they can actually pre-stress concrete beams, and they do it a couple of ways. One way is they put a tension cable that's stressed before the pour. They pour in concrete around that cable, and then they just cut it off, and the cable's already stressed, so it actually stresses the plywood and cambers it a little bit. This is exaggerated, but it there's a little bit of a rise in it so that it can take loads better. And then they do one with a conduit inside so that the concrete doesn't fix the cable, and then they can actually stress it after it's poured. They can seal one in and just jack the other and do the same thing. That's kind of interesting. So here's here's a typical thing, and we'll look at a couple of really short videos that look like this, you know, just concrete in these kind of ways. And you'll notice they do a lot of, we had a video of a house that a guy in town built, a steel frame, and he put straw bale in it. And he actually, the whole thing, none of it was welded. The whole thing was done by nuts and bolts. And they just had to line up everything. Everything was pre-drilled. And they just had to line everything up and make sure the bolts went through and you know, tighten them with a, you know, some kind of whatever fastener, the machine that they had to get a real tight grip on it. I thought that was cool. It's like a little erector set, you know, they didn't just get this, you know, shipment of beams and a box full of bolts and go at it. Then they have floor joists that are made out of steel, and they have different types, and sometimes they're pitched if they're going to be on a roof, and sometimes they're hung from the top. The wall comes down here, so the bottom isn't even bare on the wall. Sometimes the bottom is what's bearing it. Sometimes they have just one slope, you know, they're a shed type. So they have those. And then they have this thing called metal decking. And it's kind of what we saw at the beginning. They didn't call it that, but God, this stuff right here. They said steel pans. So they put a whole pan up on the beams or on the columns, and then they pour concrete into it. And that adds a little more strength, and it kind of becomes a permanent form. They don't take it down, it just stays. And we'll show some others. That's what these things are here. It's a cross section, and there's a different type. And then here, this one, they pour the concrete on top of it. So you see those. Okay, so that's it for the concrete. Gives you a little bit of an idea, right?
Yeah, those are just for slabs, those little dome things?
Well, they're connected to a pan. There's like a metal sheet, and they just are on there so the concrete kind of grabs them. These are round. So they put those on the joist or the beams if they're, you know, metal steel beams.
Oh, okay.
All across. This video we're going to look at has what's that stuff called? God, it's a metal that has little. It's like you walk on it and it's got little projections that keep you from slipping.
Mhm.
You'll see it when you do it, and that's how they do it. They just do the whole floor with some kind of
Wow.
thing on it.
Diamond plate?
So
What?
is that just for the top of the beam, or is that for an actual slab, or is that just for the top of the beam?
No, that's for the actual slab. They'll
Oh, wow.
put these sheets of metal, you know, spanning the joist.
But they're
Okay.
like corrugated. It's not like diamond plate, is it?
No, they're like corrugated, exactly. And they well, no, these are, you know, the thing I showed you before. They're actually like little cups, but they may have, I don't, you know, this is just what they have in the book. They may have see like this. They may have corrugated ones too, for all I know.
Yeah.
Just
Wow.
something, just something to grab the concrete a little bit, keep it
Yeah.
from moving.
Interesting.
Yeah. So yeah, this is a whole, but you know, actually it's pretty you know, these buildings we're going to show in these videos are sort of like warehouses, or actually one's not. It's pretty finished, but you know, skyscrapers are different because they have a lot of divisions inside, you know, for offices and residences and things. So, and they have a lot more services, you know, they have to have plumbing and electrical for each unit. So they're actually more complicated than these kind of buildings. They've done films on like the Empire State Building. They've got videos on how it was built from the beginning. They had film back then. You know, it's not that old. I think it was made in the 30s, 20s or 30s. And they filmed that. That's really fascinating. Go to YouTube and see if you can find that. It'll blow your mind. The weirdest thing about skyscrapers is how far into the ground they have to go. I mean, it's like you could spend months just digging giant holes and, you know, making sure the ground underneath is doable for a skyscraper. So
Go down to the bedrock, right?
yeah, well, yeah.
Well, like
You
New
know-
York, I was thinking about New York specifically, but
Well, New York, there's a lot of bedrock, and I think it was most of those things are on that. But
Right.
you know, there was I don't know if you heard about it. I think John and I may have talked about it in another class. There was a apartment building skyscraper in San Francisco that was built on a landfill, an unused land, a landfill that stopped being used, and they didn't have enough secure, foundation, and this frickin' building, which was like, I don't know, 50 stories or something, started tilting.
Sunk into a trash hole.
It sunk in a little bit on one side, and it was like, the top was like started going like 3 feet out of plumb. Can you
Yeah.
imagine that? And a lot of people started moving right then out of there.
Yeah.
I
Good
would have,
idea.
but a lot of people stayed. Can you imagine that? I don't know what happened to that building, but what a fiasco that was. God, that's scary stuff, huh? So I cut out the article, but I don't know. I'll have to look through my newspaper clipping and see if I can find it. It was pretty spectacular. I went, oh my God, you're kidding. Can you imagine? Not only would everybody have to leave if it got past a certain point, the city would just say, you can't live here. We can't safeguard you anymore. So the people who build it would lose all that money. Then they have to take the freaking thing down. And it's probably relatively close to other buildings, because San Francisco doesn't have a lot of, suburban land downtown. And they have to take that thing down. Oh my God. The volume of work
Nightmare.
makes me sleepy. So I'm glad I'm not involved in that one. Okay, so let's see a couple little videos on how that construction goes. I just thought it might be interesting to show that. So you can't see that yet, right? Of course not.
Nope.
Didn't that building start sinking almost right away or something?
Yeah, within the first year, maybe in the first few months. And I haven't heard, this was, 2 or 3 years, 4 years ago. I haven't heard anything, they don't do follow-up articles all the time. You could, if you research it, you could find it. Maybe I will, because that's really interesting phenomenon. Because if a building starts to tip and it reaches a point where it's going to fall or break, that's going to endanger the neighboring buildings, right?
In some places, those leaning buildings bring in a lot of tourists.
Yeah, it's true. But I think the Leaning Tower of Pisa has a lot of open space around it, if I'm not mistaken. God. Yeah, that kind of stuff does happen. You can see this now, right?
Yes.
Check this out. I'm going to show you how I afforded this car. Okay, you ready?
No,
108.
we don't want to know. So this is obviously
Story.
you can all see that, yes?
Yes.
Yeah.
Okay. You just can't hear me. It's okay. You think this is time lapse or digital? Virtual.
Virtual. This looks like a regular 8 hours for me.
God, what a lot of work, huh?
They're rolling those steel joists.
In the air. That's a pretty good trick. I love that. They also get longer at a certain point. That's pretty magical.
Yeah, we're
That's
gonna run
pretty-
out of steel. We're gonna run
that's
out of
pretty-
steel pretty quick here.
That's pretty cool, huh? I love that kind of graphic. It's just out of chaos comes this order somehow.
Nice, I like that.
Look at this whole flipping building is just columns and beams. See, now here's that. What do they call that metal? You can see a close up on it. It's got those. See, it's got those little.
Diamond plate.
What plate?
Diamond.
Yeah. So I don't know if they're going to use that as the floor or they're going to pour concrete over that. If they use it as a floor, it'd have to be a factory, wouldn't it?
Concrete? What do we have here?
What?
That concrete?
I don't know. It's like the pyramids. It's total magic. These look like concrete. Those others look like stone. These look like stone of some kind. You know, the question is this really a real building or not? So, that's amazing. That's not a warehouse, right? You know, it's got offices and stuff. So I can't imagine they would leave that floor like that. So that probably they poured concrete over it. But the next video actually shows them pouring concrete. So we'll get an idea of what that's about. They never go inside this building. I was hoping they'd go in.
Over the last few months, Americans from all walks
Sarah
of life
Palin?
helplessly watch.
Where'd she come from? Oh, not that. Yeah, don't do it on my time now. What do you think about the music?
Like I'm at Coachella.
So this is overseas. It looks like, what kind of script is that? Thailand, maybe? Cambodia? See, those are just bolted. There's your pan. No cross ones. Those are like corrugated, not cup. So it looks like these have bolts that hang or rebar that holds the wire mesh up.
Is it welded to those bolts, or it looks like I can't tell how it's attached to those bolts?
Yeah, it might be welded. But yeah, you would think they would have mesh in the concrete.
Super straight, so.
What would they be bolted to? They don't look like they're sticking all the way through.
Not through that metal floor, like they wouldn't put a bolt through that.
Yeah. Maybe they're welded to the bottom from the top side.
You know, like they welded all the bolts on and welded it to the rebar.
Yeah. Yeah, because you got to do it. You know, they can't fall down. Boy, it's kind of a different kind of construction than stick framing, huh? Okay. Okay. No, shut up. We don't want to know. Okay. Okay, so the last piece on that handout, if you have it, is I think it's an index for a Wendy's restaurant. So let me so you can all see this book, right?
Yes.
Yeah.
Print reading for residential and light commercial construction. So they do a Wendy's, you know, a brick veneer residence, and then they do a Wendy's, I think. Anything else? Oh, they do a veterinary center also. Wendy's and this veterinary center are their commercial examples. And the interesting thing is, you know, we're going to look at okay, let me ask you something. We have we're going to look a little bit at this Wendy's commercial book, the prints for it. And it's pretty early on. It's only 6:53. And we have one more class before the final. So next week we'll do the final prep. So we can either do specifications, which won't take that long, and schedules, which won't take that long tonight. Maybe stay till 8, and then just do the prep next week and go home whenever it's done. Or we can take some of this content and make it next week. And you'll have to do both the prep and, say schedules or specs. What do you think?
How long do you think the prep will be? An hour?
Yeah, isn't that what they usually are?
Yeah. Sometimes a
I
little
would
bit
say-
longer, but you,
Yeah,
I would
so,
say
so,
go longer tonight and then just do the prep next week.
yeah, okay.
Yeah, same here.
Okay, great. Let's do that. I'll try to hurry it up. I'm just going to give you a taste of the commercial stuff because, you could look at more videos, how they do a whole freaking building step by step, but that'll bore us to death. We kind of got the drift. The thing I learned was that all these buildings are alike. They got these steel frames with concrete floors. It's like really pretty uniform around the world. I had no idea. I'd never thought about it. So that's kind of interesting. Like I said, when they're hospitals or specialized places, then you get a lot more. Actually, Marcos would probably know about this. They get a lot more detailed stuff in the construction. You have a lot more services that you have to put in the slabs and in the beams and,
The plants are huge.
yeah. They just, anyway, this Wendy's no. Let me do something first. Let me go back. So go to my mistake here. Go to
You know, one thing they do for the schools, Patrick, is because it's California.
Yeah.
All our schools the new schools that we build, and I've only been here for a couple of years, so I have yet to see one go from the ground up. I'm excited to see one in the next 2 years here, but they're all basically copies, or they're already California DSA approved plans.
oh yeah. So they don't have to
So if you go like to Fresno,
yeah.
you go to school in Fresno, it's basically a cookie cutter building of that plan. They build a school here based on a plan that was already approved in another city, basically, to
Yeah.
save on money and time.
Yeah, interesting. That's an interesting thing.
Yeah,
You
so
was-
they're basically carbon copies.
Yeah. Oh, how interesting.
Yeah,
Well, yeah, I mean, I hope after they learn from, usually when they build a building, they learn a lot. They make,
they
few
make
mistakes here and
improvements.
there.
Yeah,
I
But-
hope they update them every time a little bit.
yeah. Sometimes not so much.
Yeah. Right. Oh, that's interesting. Yeah. Because, California is so bogged down by bureaucracy that, I can see why they'd want to do that, to
Well,
avoid all
and then it costs so much money. Imagine a $30 million building for them to draw up completely new plans.
Oh, yeah, and new, material list, all that.
Yeah, the costs are just crazy.
I mean, that's a huge part of those buildings is the plans, right? I mean, it's got to be,
yeah.
and they're
No,
giant. I mean,
This
I'll
school
show,
that we're gonna be building here has been started in 2015. So
wow.
it hasn't even broken ground yet.
Yeah, wow.
So
Okay, can everybody see this Unit 9 specification page?
Yep.
Okay.
Yes.
So I'll just read through the things I think are important. You should read this on your own. And when we do the final prep, I'll tell you what's going to be on the final in terms of specification topics. But specifications vary in length from a few pages on some of these simple residential prints to several hundred pages. Now, when I'm at school, I always show people this book from UCSB where they did this, one of the more recent buildings. It was the last thing. What's that guy? What's the contractor in town that did some shady stuff and got convicted?
which one?
It's an Italian name. Really.
Dario.
No, not Dario Pina. Yeah. No, a more successful, what's that guy's name? Oh, I'll think of it.
the one where his wife owned the car
Yes,
dealership?
yes, he tried to put all the stuff in her name, and it was a
Yeah.
big thing. But he was a really successful contractor until he got in trouble. But he did some buildings at UCSB, and the last one he worked on, he wasn't able to finish it. Someone else came in. But I had a student once that worked at UCSB in the maintenance program, and she brought me a copy of the spec book, and it was the size of a phone book. All specifications. That's not even the plans. That's just the specs. So it's a college, so it's a public building, and it's a public building. So it's a public university, UC. And so it was like marine biology. It was the one down as you turn to go in the library, that one in the corner there. It's got a lot of wood siding. And God, but that book was huge. I mean, I've got it. If we ever get back to the school, I'll get it out. I should have brought it tonight. I didn't even think. It's incredible. It says everything. So a few pages to several hundred pages. They are normally prepared by a person who's thoroughly familiar with construction procedures, building materials, and local government codes, obviously. The specs and the drawings, the blueprints, supplement each other because there's information that contribute back and forth, obviously. Requirements and scope: the owner, the architect, engineer, general contractor, subcontractors, material suppliers, building departments, and attorneys all use the specifications, as do the craftspeople engaged in the construction. So they use them for different reasons. The lawyers use them in case something goes wrong and the owner wants to blame the contractor. And then they get out the specs and they go, well, did you follow these specs, and that kind of thing. So they become the measuring device. The owner uses the specs to define the quality of work for the construction. The architect uses the specifications to define materials, processes, quality standards, etc. And then right on down, contractors commonly joke about specification, calling them comics. The building officials need specifications to determine compliance to local and state codes. So, when you submit prints for, to get them approved by the building department for a commercial building, you got to send in that code book, and they have to pore over that for weeks and make sure everything in that book is according to code. Attorneys need specs. What was that?
I was just gonna say, just to share, I ran up real quick to the front. This is a spec book for that new school. Just so you can see.
What's it? You have that?
I said, just to share, this is the size of a spec book for that new school.
Oh, okay. Yeah.
Just to, because I know you were talking about how big they are.
Yeah. Keep it. Let me get back to you. I have to
worries.
I have to allow you to share, but I'll do that.
Oh, okay.
Yeah, that's great. You got one. That's
4 by
cool.
8, 4 by 10 right there.
Yeah, really. So attorneys need specs to assist in the resolution of disputes. Okay, so here's an example. We're going to look at some in our plans, but work shall include all items indicated on these drawings unless otherwise noted. AIA general conditions, latest edition is part of the contract. You have to go by their requirements. There might be structural specifications. We'll look at some. They do have divisions. These are pretty general, division 1 through 33, and they vary. Sometimes they'll add and subtract requirements, but this gives you an idea, and I'll show you the ones for Wendy's in a second. No, we already covered this stuff. Yeah. The contract requirement. So the set of plans and the specs are a legal contract. We talked about that at the very beginning of the class, that the plans were a legal document. And so, the law's on the side of the document. So if you deviate from those and there's a problem, you're going to pay for it. No, 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 no. Yeah, that's all. So let's look at a few examples of those. Hold on. I wrote down Appleton prints. So this is a local architect's drawings for a house. You've seen these before. Bill Dang, architect. This is in your file.
Are we supposed to be seeing something?
Pardon?
Are we supposed to be seeing
Oh,
something?
yeah. What's wrong with you guys? You don't have X-ray vision? Sorry. Okay, there you got it, right? So Bill Dang, you've got these in your file, your Canvas file. So you got a floor plan, second floor plan, door schedule. Let's talk about schedules too while we're at it. So it's the one print we haven't talked about. And at minimal, they're doors and windows. Sometimes they'll be finished material, like baseboard or crown. If the house has a lot of varied finished material, then they'll want to schedule to separate it out and make sure you're getting the right stuff. But the doors, it'll have the door opening, and this is the rough opening. So you build it according to this, and if you frame it according to this size, you'll be fine. And then this is the type of door, and they'll have a list of types somewhere. And then they'll tell you the material of the door. Whoever orders the material, the lumberyard or the contractor, will use this to order these things. So you'll already have those on site. But finish color, and then any details. This one doesn't have a lot. It's a pretty simple house. Windows, the same thing. Nominal size, frame. So this particular one doesn't use, it lists a nominal size, and maybe those are nominal over here too. And it doesn't use rough openings, which most prints do now, because the window company puts out the rough opening, and you need that before you. So if the architect designs a certain size window from a certain company that makes this particular type of door or window, they have to get you the rough opening before you frame. Otherwise, how would you know? Now, in the old days, we used to just make the height 2 inches bigger for a door and the width maybe 2 inches, inch and a half, 2 inches. So we could tilt it if there was something wrong with the frame, and then we have shims in there. But now the nominal size, we could go by the nominal size in the old days because they were all fairly close to these. But now the nominal size may not indicate the size at all. The actual size of the window or door may be bigger than that nominal size, and that would screw you up if you were framing for it. Or if it were smaller, you'd make too big of an opening and you have to fill it up. So you want to have the exact rough opening the manufacturer suggests. And then here's a room finish one. So subfloor, that's going to be the same, but floor material is going to vary from room to room. And here's a list of the types of material. And then the baseboard will be a certain type. The wainscoting, there's wainscoting that'll be a certain type. The walls, this is the color and the material the walls are made out of, ceiling. So those could go on a schedule also. So that's a print door, window, and room finish schedule. So that's a print in the it's an architectural print in the line of prints. I left it off my schedule for some reason, so, but it's not very complicated. So, but there was a page of specs. Am I missing it? Or maybe I don't know. Sometimes all they have are general notes. Maybe. This house doesn't seem to have I could have sworn it had one. Maybe I was seeing things. That's probably extremely possible. But this Shumash one, everybody see this one?
Yeah.
This is also in your file, Shumash Learning Center. It's the second one. And we'll just sort of meander through it. Usually specs and schedules are toward the back. Okay, so here's a schedule plan, a window and door. They haven't filled it out. We need this stuff in here. So what they do is they've listed the door, that's, for instance, the doors, they've listed them, and then they have instead of putting it in a category, they just have a picture with all the size stuff. That's another way to do it. And then, there we go. So here's a spec page, structural notes and specifications. So let's zoom in on that a little bit. Structural wood. All lumber materials, unless otherwise noted or shown, shall be as follows. Foundation sills and ledgers embedded or in direct contact with concrete or masonry shall be pressure treated Douglas fir. So they don't have to say that because they shouldn't have to say that because a good carpenter would know not to put untreated wood on concrete, but they might do it. And then when the whole house was built, you have a sill that's supporting the whole house on the foundation and it's not treated. That's a problem, huh? So then the lawyer just goes to this and says, right here, I don't know what they would do. You can actually remove sill plates after a house is built, believe it or not, but it's expensive and a mess. So they have stuff like that. Plywood sheathing, it tells you what kind of plywood's expected. Structural steel and miscellaneous metals. Masonry, let's see what it says about building code. The contractor shall inform the structural engineer in advance of reaching the following stages of construction. So they're tying this to structural engineer drawings that are important. That has to be spelled out. Concrete tells the kind of pounds per square inch and the mix ratios and all that kind of aggregate. So you can see it's pretty important to have this. And this is, I can't believe that's all there is, but there may be more. Maybe I just copied one page to show you, but anyway, so you get the idea, yeah? The Laguna Blanca print, I won't bore you with it, but it's got, it doesn't have a door window schedule on it, on that particular set, but it doesn't have a separate spec page, but it's got like plumbing and electrical and fire specifications on the plan or section pages. They've integrated into the other pages. So you can go check that out. Okay, well, that was easy, huh? So does everybody have an idea of what specifications are?
Yes.
It's a separate print in a roll of prints, usually. And a small, like Armando's prints were preliminary prints where the customer hadn't okayed the, the plan or the project. And in fact, in that case, they didn't. So he didn't put a lot of specs because he didn't want to waste his time. But in the other one by Dang, the Dang prints, first one we saw, there were some specs I don't know if there's a separate page, I can't remember, but they were integrated into the other prints. So in a simple residential house, they may not have a separate page. And to the other extreme is commercial buildings where they'll have a book. Oh, Carlos, you got your book with you?
Oh, yeah, I thought everybody could see it already.
Oh, they can, if you hold it
Yeah.
up.
Yeah, it was just, that's the spec book.
Can everybody see that? That's for a school building?
That's for one school building, yeah. And then one thing I was gonna mention too is on commercial plans, we have multiple rolls of plans, and usually they're like phase 1A or phase 1 and then phase 2B.
Oh, wow.
Because they're built in phases sometimes.
Yes.
Yeah, so just something to know.
Yeah. But do they constitute one whole thing, or are they actually separate rolls with multiple prints within?
No, they're separate rolls.
Yeah.
Yeah,
Well, otherwise it'd be a big roll. Yeah.
yeah.
Wow.
It's,
Interesting.
yeah.
Have you worked on those in terms of the initial construction?
No, I've never, like I said, I've never seen one go from the ground up.
Yeah.
Because a lot of our schools, around here, some of these schools are 30 years old.
Yeah.
So I've never
So
had.
you're just going in to renovate and this and that,
Yeah,
right?
we just on the maintenance side of it for the most part.
Yeah.
Sometimes we got to take down a wall or whatever, but
Right.
very minor. And then some of the new construction that I've seen just a glimpse of were just kind of additions, like a 2-story addition
Yeah.
to an existing school.
Yeah.
And
Okay.
they call those what do you call it? P2Ps. It's like a temporary to permanent, or permanent to, from a temporary building, like
Right.
those like portables.
Yeah. Yeah.
Yeah. And the
Wow.
portables are supposed to be temporary, but sometimes they're on the schools for like 25 years.
Yeah. That's the joke. Yeah.
Crazy.
They're
yeah.
they're never temporary.
They're never temporary.
The portables, the room 23 and 24 at the Wake Center. Some of you haven't been there because we've been virtual for a while. But those two, if you go to the summer school class, you'll see it. Those two buildings were portables we got from an elementary school in Carp that was being destroyed, and they were given away. They were selling those portables, and you can imagine how old they probably were.
Well, it gets to the point where we're doing work, putting in new flooring and stuff like that because they've been there so long.
Yeah.
And then some of them we lease, and some of them we own.
Yeah.
And I think one time they ran into an issue because there was a construction project and they demoed one, and it turned out to be a leased one.
Whoops.
Yeah, that was a big whoops.
Yeah. Okay, I'm going to show you this Wendy's real quick, and then we'll pretty much be done. So, I'm about to put my glasses on. So they've got that list on your you don't have to see this clearly, but that list of categories I showed you in the spec, it's on your spec handout. Well, they've got that same list, only under each category, they've got, 10 to 20 items. This is a Wendy's. This is a 1-story. See if there's a picture of it anywhere. I'll find a picture. But they also have on these spec pages in a commercial building, they'll have contractors work the premises, contract sum. So they'll have the whole business contract on it too. You know, not just the building particulars. And they'll have permits, performance and contract bond, letter of credit. So all the insurance and bonding they need, they have to have that in the thing too. And then they have permits and insurance, method of payment, risk of loss. This is heavy duty stuff. Default by contractors. They have consequences of what'll happen if whoever screws up. Default by contractor, inspections, construction manager, protection of work and property. You know, while it's being built, you've got to protect it and protect people from getting injured in it.
Hey,
Compliance
Patrick,
with-
on a resident, like in the commercial side, there's also like warranty periods and stuff like that. Is there something like that on residential stuff?
A little bit, but not anything like this.
Okay.
And I don't think they put the contract in the, unless it's a big giant, you know, semi-commercial residence. The contract's usually a separate. Bunch
I
of
mean, like the
paper.
contractor, even if it's just a small residential job, they're probably liable for a certain amount of
Right.
some kind of liability, right?
Right.
Yeah.
No, this has to be fixed because the money's so big.
Oh, yeah, no, but I was just curious on the residential side because I'm not familiar with the
Right.
residential.
And then there's Wendy's right to audit, whatever that is. They can audit the papers of the contractor, I guess. That's a good right to have, right? So you don't get, here we go, Division 2, site construction. Wow. We haven't even got into the construction yet. Here we go. Excavation, backfilling, grading, all kinds of requirements for that. Asphalt paving, you know, because Wendy's has a parking lot, right? So that's part of the deal. Asphalt paving, concrete paving, striping and parking blocks. I mean, think of the details in a commercial, you know, food service place. Curbs, landscaping, utilities, slabs and footings, masonry. That's why these things are phone book size, like Marco showed us. And a school's a lot bigger. Wendy's, I mean, this is just you know, Wendy's are never very big. This is just a typical Wendy's, but it requires all this specification. And then you got mechanical, right? You got a restaurant, so you have all these, you have ovens and freezers and refrigerators, and all that stuff has to be done right because you could poison people with food that wasn't kept right or cooked right, you know? So giant, I mean, look at this water heater. Stuff takes 2 pages. And then there's, of course, a lot of pictures, which I'm not going to show you. I'll spare you. But that's just, I don't know if they must have schools that teach commercial construction, right? I mean, it's not a typical community college thing because, you know, we're not set up to go that far into any particular subject. It's just like labs in the chemistry. They don't have any nuclear labs or any, you know, really sophisticated things. There's limits. Probably at a university. Did anybody graduate from Cal Poly? You know, they have a management program and, you know, you've got to teach management for commercial buildings too, right? Construction.
Yeah, it's like project management.
Yeah, so they probably have one there. Somewhere they have commercial things. I just don't know of any because I've never been, you know, it's never been my thing. God, you worry enough trying to get a house, just a freaking house built, right, John? Look at Rodney. I mean, he worries himself silly because, you know, mistakes are made on a job. I mean, that's just a residence. Of course, his are pretty highfalutin residences, but God, a hospital. I mean, I remember once what's that guy's name? He was in San Ynez Valley. It was a Hispanic name. Urquiz or Irk. Anybody know that guy? And we were at the Detention High School in the San Ynez, you know, the one, what was it called? It's in Red Rocks. They've got a boys' school there. It's actually a camp, and then they have high school. And we used to do a class there, and I'd come in and talk to them. And oh God, what a mess!
Is it like a school for kids that are kind of a little troubled, or
Yeah, that have been incarcerated.
is that Grizzly Academy?
No, it's called. What'd you call
Oh.
it?
Grizzly Academy?
No. It's
Oh,
got well, unless they changed the name. It was a county facility. You know, when one of the fires was out there, they had to evacuate it because it was getting too close.
Is
Los
that
Prietos Boys Camp, right?
Los Prietos, yes, thank you. Los Prietos Boys Camp. And they have a high school, it's called something else. The high school there.
everyone called it camp or something, right? There was some.
Yeah. I forget what I was going to say about that, but anyway.
Camp. It's fun.
Yeah. um, yeah, so any is that everything? Yeah. Yeah. Everybody goes, yeah. So next week is we're winding down. Your teacher's really winding down. We're going to have the final prep, so really try to make it next week, and I will record the final prep. So if, you know, God forbid, some kind of accident or emergency you have to deal with, you can't make it, I'll have a recording for you to watch, and you can relive the events of the class, as exciting as they are. So be here and we'll go over. I'll tell you what's going to be on the test like I did for the midterm. So it should be pretty easy for everybody. Any questions before we depart? That wasn't bad, huh?
That was a good one.
Yeah, we'll get the heck out of here. And next week's will probably be, I can't imagine it taking more than an hour and a half at the very most, which is what tonight's was. You know, it's going to be like last time. It won't be that hard. You guys will have covered most of the stuff. Okay.
I have an interesting estimating question.
Yes. Go.
So let's say theoretically you are doing alternating 1x4 and 1x6 on a ceiling,
Yeah.
and you need to estimate the amount you need. So you have a 232 square foot ceiling, random number.
Well, I
Is
would
there-
divide the whole ceiling by a 1x5, and then divide the number of 1x5 in two, and have that number for 1x4 and the other half for 1x6.
So I
That's one way.
I don't know if there's a better way. I had about 15 minutes to figure it out today. So what I did is I took the square footage of one linear foot of 1x6 and 1x4 combined, which is
Yeah.
0.75 of a foot, and then divided the total by that.
Yeah, there's a couple ways to do it. That's a good way.
Is there another way that's more intuitive?
No, you know, I would add, another way is to add the 1x4 and 1x6. So you got 3.5 and 5.5 is 9. And, you know, I tend to do it as strips and not as volume, whole area. It's interesting you did it that way. But I would take the width that you're covering, you know, and divide it by 9. And that would tell me how many combinations of those that'd be. So I'd order half of that for 1x4 and half for 1x6. And then I'd just multiply that by the length.
The one thing I liked about the square footage way is
Yeah.
it gave me a number, and that was a linear foot of 2x6 and a linear foot of linear foot of 1x6 and the linear foot of 1x4 I needed.
Yeah.
I
Yeah.
don't know.
And I would order a little extra for waste. And if you know the length of the room, that stuff can waste pretty easily because you can end up with a bunch of little stuff that you didn't anticipate.
Well,
So,
the room is 21 feet 2 inches, so it's kind of an awkward length.
so you don't want to have like just two pieces, right? Because then they'd all be joined in the middle. So you want to have at least three, at least three pieces. So probably you could go, I would order 21 feet. You say I'd order like 8-footers, 3 8-footers for the length. I just order a bunch of 8-footers of the different sizes.
I'm planning for 16s and 8s, I think.
Yeah. So that's going to be a little different in terms of your square footage because of, you have to order a specific size. So make sure you account for that waste.
Yeah, I added 15%, so that should
Yeah.
be more than enough, and it's returnable, so it won't.
Yeah. That's why your way is probably better, but it all depends on the person. I'm so paranoid of making mistakes. I will actually lay out the room and figure out how I want to do the pattern and what size wood fits that best. And you can't do an area thing when you do that because it's just harder.
Yeah.
So, but it's faster and more efficient to do an area thing and add some waste to it.
Well, I did a Western red cedar patio cover,
Yeah.
and I got about 30% off on it.
Yeah.
Trying to overcalculate, and I pulled it. It was a SketchUp model. I pulled the boards from.
Yeah.
And there's no return. You can't return it. It's all
Oh,
custom.
yeah.
That is out like $1,600, but it's a good learning experience.
Yeah, that's a tough one. You don't want to be short. Although if it's handy, if the place is near you and you don't have to order it, then you always go short and you can go pick up more. But if you've ordered it ahead of time and it took a month to get and it comes from Madagascar, just order it and bite the loss and use it, like you say, somewhere else. He's always trying to get me to construct out of this extra wood. Hey, can you use, 50 linear feet of, acacia from Mozambique? No, John, I can't use it.
Yeah, I have a full carport full of remnants. Whatever project you have, you need like 4 boards.
Yeah, well, when you do a house that wants a remnant wall, a really spectacular wooden wall, just put it all in there together. Nobody will be able to duplicate that ever. Okay, guys. Bring your questions to me, and I'll give you answers. Whether they're the right answers or not remains to be seen. But I've got a lifetime of experience. I've probably covered a lot of the stuff you'll come into. So feel free to ask me stuff. And you can also ask me stuff online without having to take class time, and I'll entertain your questions. I'll tell you if I'm capable of answering them. If it's an area I don't know anything about, I won't try to fake it. But okay, so everybody ready for next week? Know what you're doing? All right, have a good night tonight, okay?
You too. Thank you.
And I'll see you next
Patrick.
time. Yeah, all right, guys. Oh, wait.
Oh.
Should I take roll real quick?
Oh, yeah.
I should. Some of you might have left and you can argue with me next week, but Miguel? Jesus?
Here.
Alec, you're here, or we're here. Hamar, did you make it tonight? Marcos was here. Colby, did you make it?
Yeah.
Great. Hugo is in Mexico. Lucky guy. Eric Mendez.
Here.
Great. Thank you. Dylan, I saw ahead of time. Kevin.
I'm here.
Duke's here. Brandon, were you here? Yeah, Brandon's always here.
I'm here.
Yeah. D'Angelo's here. John's here. some of you I talked to, so I know you're here. Michael Silva
Yeah.
and Jose Nunez,
Yeah, I'm here.
John Tapia, I saw. Johnny Vasquez. And Jacob, are you here?
Yeah, I'm here.
Okay, great. Thanks, guys. See you next week.
All right. See you,
All right,
Patrick.
bye-bye. All right, see ya.